Hello and welcome. In today's class, we'll see how we can write a Java program to create a linked list and perform some basic operations like adding a node to the linked list, deleting a node, searching for a node, and displaying all the nodes currently in the linked list. So let's start with the import statement. Then we create a class node. So because a linked list is made up of nodes, that's why first of all we have to define the nodes. And that's why we take the help of a class. A class helps us to create user-defined data type. And that's why we are creating a node with the help of a class. So we are taking two data members here. One data member to store the actual data, and the other data member will be used to connect to the next node. So node next. Then we can create some constructors. So let's create a non-parameterized constructor. So if the user doesn't provide any data, then by default we are going to take data as 0 and next as null. Similarly, we can also have a parameterized constructor. So if the user is passing the data, then data will take that value, and here also next will be null. Null means next is right now not pointing to any node. That is the meaning of null. So now that we have defined the node class, we can create the linked list class. So we will now write class linked list. So we will create a variable start inside this class that is always going to point to the first node in our linked list. And then a constructor linked list. Here by default start will be null, means initially our linked list is going to be empty. Then we can create a function. Let's say add node. So we will need a parameter d, the data for that node, and we will create a node first of all. So node n equals new node with the parameter d. Once the new node is created, now we have to insert it. Now there are different situations that we might need to consider while inserting a new node. So for example, if start is equal to null, that means right now our linked list is empty. In that case, insertion of a new node is very simple. You just have to point start to where n is pointing to. So n was pointing to a new node. So now start will be pointing to that same new node, and that's why the new node becomes the first node in our linked list. Else, we can create another variable ptr that is going to point to the same node where start is pointing to, and while ptr.next is not equal to null, ptr is equal to ptr.next, means ptr is starting from the first node, and as long as that node's next is not null, ptr keeps moving ahead, keeps moving to the next node. And as soon as the next part is pointing to null, the ptr stops there And then we can write ptr.next equals n. So if we have a non-empty linked list, then we are moving to the last node, and then the new node is added to the end of that last node. So that means a new node is always appended to the linked list. That is the idea here. Next, we can also create a function to search for a node, whether a node is available or not. So we can write public void search node. And here also we will require the data to be searched. And if start is equal to null, then there is nothing to search. Our linked list is empty. So we'll simply print linked list is empty. Else, again we create a new variable ptr that is going to point to the same location where start is pointing to. Now while ptr is not equal to null, means as long as ptr is getting new nodes, we keep checking its data using if. So if d is equal to the data in the current node pointed by ptr, so in that case we print that d is available. Okay, and after printing the message, we can return from the function, return back from the function. We don't want to continue further. Otherwise, ptr equals ptr.next. That means if the data is not matching, then we keep moving to the next node as long as there are nodes in our linked list. And then over here, outside the while loop, we can print d is unavailable. So when the while loop becomes false, it means that we have reached the end of the linked list. Now there are no more nodes left. And that indicates that the data that we were looking for is not available. So we are printing, and once we come outside the loop, that means we could not find the data that we were looking for, and so we print d is unavailable. And then we can create a function to delete a node. So public void delete node int d. Now in the delete node, again, first of all, we are going to check whether our linked list is empty or not. So if start is equal to null, then it's not possible to delete any data. So in that case, we print linked list is empty. And in that case, we don't want to move any further also. So we can add one more statement inside if return statement. So we exit from the function. Otherwise, the data that you want to delete, here also we have to consider multiple situations. So for the first situation was whether the linked list is empty or not. Now the second situation is that the data that you are going to delete, is it the first node? So if d is equal start dot data, That means we are going to delete the data that is present in the first node. So in that case, we will simply tell start that you point to start dot next, means you point to the next node instead of pointing to the current node. And that's how we are able to delete the first node. And if it is not the first node, if the node is somewhere in between or at the end, then in that case there will be one more case. So that is a different case, and that's why we will write node previous equals start, means previous is going to point to the first node, and node current equals start dot next. So current is going to point to the second node. Now, while current is not equal to null, as long as we have a node in the current variable, if d is equal to current dot data, then what do? We tell previous dot next to point to the, not to the current, but current dot next. That means the current node is now unlinked, and break. We don't want to continue any further in the while loop. We want to break because we have found the data that we want to delete and we have deleted the node. So this is our if part. And else, if the data is not matching, then in that case previous equals previous dot next and current equals current dot next. That means previous and current keeps moving ahead. So next time previous will point to the second node and current will point to the third node. That's how it keeps moving ahead. And that's how the deletion takes place in the linked list. And now we will create another function called display. So we'll write public void display. And here, if start is again equal to null, then again we are going to print the same message that the linked list is empty. So we write system.out.println linked list is empty, else node ptr equals start, while ptr is not equal to null, we print the data. So ptr dot data, and we also try to print an arrow to show that it will be linked with another node. And then after printing the current data, ptr will go to the next node. So ptr is equal to ptr dot next. And once the while loop ends, we print in double quotes, we print null at the end to indicate that the last node is not pointing to any other node. So null. So that's our display function. And now we create our main function. In main, we create an object of the linked list class. Like this. And we also create a scanner object. So scanner in equals new scanner system.in. Now we are going to create a menu driven program here. So we also will be giving here an infinite loop. It will soon be clear why we are giving an infinite loop. So inside this infinite loop, we are going to display a menu to the user. The first option will be add node. The second option will be delete node. The third option will be search node. The fourth option will be to display the nodes. So display nodes. And now we will give a message using print. Enter your choice. So int choice equals integer dot parseInt in dot next line, and then we put it in switch. So in case 1, we need to know the data that the user is going to add. So we give a message data to be added. So int d equals integer dot parseInt in dot next line, and we just call the function, so add node, and pass the data d, and then we call the break keyword. In case 2, we want to delete a node. So again, we will give a message to the user that you enter, or let's just write data to be deleted. And we are going to use the same variable d here. So we are not going to write int d again. We just reuse it because that variable exists in case 2 also, this variable. So d is equal to integer dot parseInt in dot next line, and then we call the delete node function. So obj dot delete node d, break. Then case 3 is for searching. So system dot out dot print data to be searched. So d equals integer dot parseInt in dot next line, and obj dot search node d, and break. And case 4, in case 4, we just have to display the nodes. So obj dot display. Let's name it display. Okay, let it be display. So display, break, and then we create a default case where we can print a message by, and then we return from the function main and stop the program. So our program is complete, and we have created this infinite while loop so that again and again this menu appears to the user as long as the user doesn't quit the program. So let's execute this program. Java C linked list dot Java. Now there are certain errors By mistake, I have given 2 dots here in line 72. So let's check line number 72 here. So we have to correct this, save, and try again. Now line 44, illegal start of expression. So let's check what's wrong in line 44. Alright, so here we had to close the search node function like this. And now we have to shift all of these to the left and remove that extra curly bracket. Let's save and again try. Yeah, so now we can execute the program. So you can see a menu is appearing. Right now our linked list is empty. That's why if you try to delete, if you give option 2, and it will ask for the data. Let's say you want to add, you want to delete 5, but there is no data, and that's why it directly prints linked list is empty. So let's add few nodes. So I give option 1 and I'm entering 10, then again 1, 20, again 1, 30 or 3, let's say, again 1, 40 and 50. So now if I want to display all the nodes, I will use option number 4, and you can see this is our current linked list with 5 nodes. And let's say I want to search whether 3 is available or not. So I give option 3 and data to be searched 3. So yes, 3 is available, it is showing here. And let's search whether 100 is available or not. So again I give option 3 and the value 100, and it is displaying 100 is unavailable. And let's delete the first node. So I give option 2. The first node was, I think, 10. So we give 10 and now check using display. So you can see 10 has been removed and now we have 23, 40 and 50. Let's delete a node in between. Let's say delete 3. So again I give option 2 and I give the value as 3. So again I give option 4 to check, and now you can see 3 is not available. 20, 40 and 50 are there. Let's delete a last node also. So option 2 and 50, and let's check 20 and 40. And once you are done, you can stop by giving any other choice. Let's say option number 5. 5 is not there, so it will go to the default and the program will stop. See, so it is now printing by and the program has terminated. So this is how you can create a linked list program in Java and perform these basic operations. So I hope you have understood and gained some concept on linked list and how to write a program on linked list. Thank you for watching and see you soon in the next class.